Welcome back, everyone. Today we're going to talk about odds and expected value. Odds are used by casinos, racetracks, and other gambling establishments to determine payoffs whenever bets are made or whenever lottery tickets are purchased. But they're also used by insurance companies in determining the amount to charge for particular premiums. Odds are related to probability, and so we're going to talk about how they're related and the differences in this section. In order to compute the odds in some situations, it's very similar to computing the classic probability. If an event has A, number of favorable outcomes, and B, unfavorable outcomes, then the odds in favor are written as A over B, or as a ratio A to B, and the odds against are B over A, and so the fractions just flipped over. So let's just take a look at this in terms of a football game. So in a recent football game, the odds for the home team to win were 5-1. So if we wanted to write the odds against the home team winning as a fraction and a ratio, well, the odds against the home team winning, if the odds to win are 5-1, then the odds against are going to be 1-5, or as a ratio, 1-5. If we want to write the odds in favor of the home team winning, well, that's 5-1, or 5/1 as a fraction. So what this means is that with these odds, if the game was to be played 6 times, then we would expect that the home team would win 5 of those times, and the home team would not win 1 time. So let's take a look at an example of rolling dice. What are the odds in favor of rolling a prime number sum with a roll of 2 dice? And then what are the odds against? Well, in favor are going to be the favorable outcomes, A, and then we need to know the unfavorable outcomes, B. Prime numbers between 2 and 12 include 2, 3, 5, 7, 11, and that's all. So the number of favorable outcomes in this case, and so if you count up all these possible outcomes, you'll find that the total number of favorable outcomes A is 15. And the unfavorable outcomes would be 21, because there are 36 possible outcomes, as you can see in the table. So we can write the odds in favor as a fraction, A over B, or 15 over 21, and we can simplify that. We just divide them both by 3, 5 over 7. To write the odds against, well, it is just B over A, or 21 over 15, which in this case is 7 over 5. And so the odds in favor of rolling a prime number sum when you roll 2 dice, 5-7, and the odds against rolling a prime number sum is 7-5. If we know the odds in favor of an event, then we can determine the probability that that event will occur by just solving this formula. And notice that A is the number of favorable outcomes, A plus B is the total outcomes, the total number of outcomes. And so this is essentially the same probability formula we've used before, but we're just using the odds to determine the probability. So in the previous example, the odds in favor of the home team winning were 5-1. What's the probability that the home team will win? Well, A are the favorable outcomes, which is 5. B are the unfavorable outcomes. The probability that the home team will win is 5 over 5 plus 1, which is 5 over 6, which is equal to 0.8333, or about 83.33%. To find the probability that the home team will not win, this probability is just going to be based on, in this case, the favorable outcomes are the team not winning, which is 1 out of 6, or 0.1667, or about 16.67%. And notice if we add these two together, we will get 100%. Similarly, if we know the probability of an event, we can determine the odds in favor or against that event, just using the formula that you see here. If we're looking for the odds in favor, it's the probability divided by 1 minus the probability, and against 1 minus the probability divided by the probability. Notice the fractions are just flipped over. So the probability of getting exactly 1 pair in a 5-card poker hand is 0.423, or 42.3%. We want to find the odds in favor of getting exactly 1 pair and the odds against. The odds in favor of E are going to be given by the probability of E, probability of the event divided by 1 minus the probability. So in this case, 0.423 divided by 1 minus 0.423, 0.423 divided by 0.577, and when we divide the two, we get 0.7331. To find the odds against, then we're just going to use the opposite formula, or we're going to flip the fraction, which will just flip the decimals over here. 0.577 divided by 0.423, which equals 1.364. According to the American Cancer Society, the probability of an American female developing some type of cancer at some point in her life is about 1/3. Find the odds in favor of and against a woman developing cancer. So in favor, well, the probability is 1/3 divided by 1 minus 1/3, which is 1/3 divided by 2/3, which is 1/2, against 2/3 divided by 1/3, just flipping this fraction here, and we get 2. And so we could say that the odds of developing cancer, if you're an American woman, is 1/2 to 2, which is the same thing as 1 to 4. So this means that 1 out of every 5 American women may develop cancer. So if we're dealing with a situation where we have some type of numerical outcome, such as rolling a pair of dice and adding up the numbers, and we know all of the probabilities of that situation, we can determine the expected value of what we might expect from just a random result. The expected value is what you would expect to find if you were to repeatedly perform the procedure, measure the outcomes, and then essentially find the average outcome. We can only find the expected value with data that are numerical, because there's no way to find the average of a category. So let's see if we can find the expected value when we play a dice game. You pay $1 to roll 2 dice. If you roll a 5 or a 6, you get your $1 back plus 2 more. If you don't roll a 5 or a 6, you get nothing, so you lose your $1. The goal here is going to be to find the amount of money we would expect to win if we played 100 times. So first, let's find the probability of winning and losing. On the right here, we have all the possible outcomes of rolling 2 dice. And so we need to figure out how many possible ways we can get a 5 or a 6. And so if we just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9 out of 36, which gives us a probability of 0.25. If there are 9 ways to get a 5 or a 6, then there are 27 ways to get everything else, which will give us a probability of 0.75. So now that we know the probabilities, we want to determine the value that will be related to each outcome. So we're interested in the money that we're going to win in this game. Right? So remember that it costs $1 to roll, and you'll win $3 if you roll a 5 or a 6. So if we pay $1 and win 3, the value of rolling a 5 or a 6 is just going to be $2. If we pay $1 and win nothing, the value of rolling everything else is going to be negative $1. We lose $1. So now to find the expected value, we want to multiply the outcome value times the probability. So x times p of x and x times p of x, and then we're just going to add all of these together. $2 times 0.25 is going to leave us with 50 cents. Negative $1 times 0.75 is going to leave us with negative $0.75, or losing 75 cents. And so the expected value is just the sum of these two values, or in this case, 50 cents minus 75 cents, or plus negative 75 cents, which leads to negative 25 cents. And so what this means is what we can expect from a roll on average is to lose 25 cents. So if we were to roll 100 times, we can just use the expected value of x times 100. And so we'd expect to lose 25 cents on an average roll times 100 rolls would mean that we would lose $25 over the course of 100 rolls. And so this would not necessarily be a game that you would want to play. We can do a similar thing with carnival games. Many of you likely remember the game where you have ducks in a pool and you just pick one and there's a dot on the bottom and the dot determines what prize you get. So we're going to pay $1 and we're going to select one out of these 50 ducks that are in this pool and we're going to get some type of prize. So let's find out what the expected value of the prize would be. There are 20 ducks with red dots. So the red dots, and in this case you lose the money that you paid. So for the red dots, the value is going to be minus $1 because you lose the money that you paid, and that probability is 20 out of 50, which is 2 out of 5, or 0.4. For the ducks with the orange, there are 10 of those, 10 out of 50, 0.2. And here we're going to win a sticker that has a value of 5 cents. And so we paid $1, we win a sticker that's worth 5 cents, and so we've lost 95 cents. For the ducks with the green, we win a small toy that's valued at 10 cents, so in that case we lose 90 cents, and there are again 10 of those, or 0.2 probability. For the ducks with the blue dots, we get to play again, and so this nets us a value of 0, and the probability 6 out of 50, 0.12. And then finally, the ducks with the purple dots. Here you'll want a stuffed animal that's valued at $4. So the value of your pick would be $3 when we subtract the one that you paid to play. There are 4 ducks with purple dots. 4 divided by 50, 0.08. So to find the expected value of a random pick of a duck, we just need to multiply the value of our outcome times the probability of that outcome, and then add them all up. So the expected value is going to be -1 times 0.4 plus -0.95 times 0.2 plus -0.90 times 0.2 plus 0 times 0.12 and then plus 3 times 0.08. And if we just write out all of these terms, -0.40 plus -0.19 plus -0.18 plus 0 plus 0.24. And so the expected value of picking a random duck is -0.53, or a loss of 53 cents. So if you pay $1 to play the game, you can expect to lose 53 cents every time you play. Finally, we can find the expected value of a particular situation if we know the probability of all the possible outcomes. So the profit made by a small ski resort depends largely on the weather. In a season that has more than 75 inches of snow, the resort will make an average of $250,000. If the snowfall is less, between 40 and 75 inches, the profit's $160,000, and if it's less than 40, it loses $70,000. The resort gets over 75 inches of snow 40% of years, between 40 and 75, 45%, and then less than 40, 15%. And so we want to determine the resort's expected yearly profit. Let's just build a small table here. We want the event, and then the value of the outcome, or in this case the profit. So this will be our X value. And then we want the probability. There are 3 different outcomes that are possible. First of all, if we have greater than 75 inches of snow, then the resort is going to make $250,000. And this happens 40% of the time, or a probability of 0.4. Between 40 and 75, then the profit is going to be $160,000, and this happens 45% of the time. And then finally, less than 40, the resort loses $70,000, And this happens 15% of the time, or 0.15. So now to find the expected value of the yearly profit, we just want to multiply the value of each outcome times its probability and add them all up. So 250,000 times 0.4 plus 160,000 times 0.45 plus negative 70,000 times 0.15. And if we multiply all these values and add them up, this is 100,000 plus 72,000 minus 10,500. So the expected value of the yearly profit, about $161,500. There's an additional video on expected value in this week's notes. Please pay attention to that. That may help you with some of these problems. If you have any further questions, please let me know.